let's have a look at the surface features of the liver, which we can see. This little man here is indicating the gross position of the liver, but we can see that this is going to be down the right side, so we have this nice large right lobe of the liver. We have this much smaller left lobe. So on this anterior view of the liver, we can see the diaphragm up here, and we can see right and left lobes. We can see that these right and left lobes are separated via the falciform ligament. Separated via the falciform ligament. And this is a really important ligament as it connects the liver to the anterior abdominal wall. So if we remember the peritoneum that's attached to the anterior surface of the liver, this visceral peritoneum, that's going to be running all the way across the liver. In this direction, it's running all the way across the liver. We can see it here, and we can see it here. And then, when these two parts of the peritoneum come together, they unite and then extend to the anterior abdominal wall. So here, they're just uniting and then extending towards the anterior abdominal wall. And that forms your falciform ligament. We can see the same happening up here with the coronary ligament projecting to the diaphragm. This helps to support the liver in its position. If we imagine the anterior abdominal wall is here, and this is the liver, which we can see here, and then spanning the anterior abdominal wall towards the liver, we have the falciform ligament. Then here, where the falciform ligament finishes, we have what's known as a free edge. So this is your liver, this is your anterior abdominal wall, and this is the falciform ligament. And we can see that spanning is the falciform ligament, and its free edge is a structure known as the round ligament of the liver. And this is really important because this ligament used to be a patent blood vessel. It used to be the umbilical vein that allowed blood to pass into the developing fetus from the mother's placenta. And blood passed through this free edge of the falciform ligament within the round ligament of the liver now, within the umbilical vein. It would then run up the posterior surface of the liver, which we'll see in a moment. So here we can see the posterior surface of the liver. We can now see again, we have this right lobe that's over here, and we have this left lobe, which is here. But we can now see for the first time, left lobe, larger right lobe. We have these two other lobes positioned here and here. One position next to the inferior vena cava, the other position next to the gallbladder. So we can see that this one that's positioned next to the inferior vena cava, this lobe here, is known as the caudate lobe. This is the caudate lobe. This is the third of those anatomical lobes. We then have the lobe that's positioned next to the gallbladder, and that is the quadrate lobe. And we can see the quadrate lobe is here. So we've got these right and left lobes, and between them we have the caudate and the quadrate lobes. There's a fissure between the left and the caudate and the quadrate lobe. So this fissure running down here is an important fissure as it contains the round ligament of the liver. It contains that round ligament of the liver, which is now going to run up in this direction. And it becomes, as it's running on this posterior surface of the liver, the ligamentum venosum. It just changes its name. And ultimately, this would be taking blood, oxygenated blood from the placenta. It would bypass the liver, and this would go directly into the inferior vena cava. As we no longer have the placenta attached since we were born, this patent blood vessel, this umbilical vein, becomes fibrosed, and then we're left with the ligamentum venosum. That's running in this fissure between the left lobe and the caudate and quadrate lobes. Between the right lobe, so this lobe over here, and the caudate lobe, we find the inferior vena cava, and between the right lobe and the quadrate lobe, we have the gallbladder. The gallbladder is storing bile. Between the caudate and the quadrate lobe, we have this region here, and this region is known as the porta hepatis. If you remember the portal triad running in the free edge of the lesser omentum in the hepatoduodenal ligament, it contained 3 structures. And those 3 structures are now passing towards this opening at the liver, this kind of gateway to the liver that allowed these vessels to pass in and out. So at the porta hepatis, we find the same 3 structures that are in the portal triad. We find the hepatic portal vein, which we can see here. We can see the hepatic artery, which we can see here. And we can also see the bile duct, which we can see running out here. These 3 structures passing or leaving to and from the liver ultimately then run in the portal triad. Remember, in the free edge of the lesser omentum. And that's how these structures can pass into the liver or away from it.